Hi students, welcome to physics class. Today's class is about moving charges and electromagnetic induction. Quick review. First of all, the birth of electromagnetism. In this, we learn about Oersted discovery of electromagnetism. Previously, it was thought that electricity is different, magnetism is different. But Oersted experiment concluded electricity is related to magnetic field. Key concepts in this is moving charges produces magnetic field around them, and two types of fields are there: electric field, magnetic field. B is nothing but it is a magnetic field, and it has both magnitude and direction. Superposition principle applies for magnetic fields. Superposition principle means a net magnetic field is always equal to sum of the individual magnetic fields. This is called as superposition of principle. Next, the magnetic force always is equal to Q of V cross B. That means only moving charge experiences magnetic field. Force always exerts on a moving charge. Suppose the charge is at rest, means there is no magnetic force acting on that charge. So here if you see the current, means moving charge is moving with respect to time. So it produces a magnetic field. So the compass needle is also having north pole, south pole, right? So according to thumb rule, what we can say? So there is a deflection in this direction, magnetic field, and current in this direction. Okay, so the magnetic field is set up in this direction. That's why he is showing with the magnetic lines of force. The key discovery in this is electric current deflects magnetic compass needle and proves moving charges creates magnetic field. Moving charges only creates magnetic field. If the charge is at rest, there is no magnetic field existed, and there will be no force existed, magnetic force. Field nature. B is a vector field. It has direction. Always moves from north pole to south pole. And it is a closed loop. Magnetic field lines are closed loops. Right hand thumb rule is used to detect the directions. Magnetic force and Lorentz force. Magnetic force means just now we learned that F is equal to QVB, Q of V cross B, that is QVB sin theta. In any angle direction theta is given means. Lorentz force means the sum of electric force, magnetic force. Electric force is QE. Electric force is QE, and magnetic force is nothing but QV cross B, right? So if we add these two, we will get the Lorentz force. force on charge q moving with velocity v in electric and magnetic field. Next, a magnetic force only, that is qvb sin theta. Force on moving charges, magnetic force is 0 if the charge is at rest. If the charge is not moving, there is no magnetic force existed on that charge. Next, perpendicular to velocity, magnetic force is acting on the charge to change its direction of velocity. It will not change, it doesn't change speed. Okay, speed will not be changed here, only direction alone changes direction only. Magnetic force can change the direction only, it cannot change the speed of the charge. Okay, that's why the work done will be 0 by the magnetic force. The work done by the magnetic force will be 0 because force is perpendicular to displacement in this case. Okay, so that's why does no work. And which rule shows the direction? Right hand rule. Thumb, forefinger, all the fingers shows the magnetic field, and the thumb shows you the current direction, magnetic field direction, and the palm will show you the force acting on the charge. Okay, so this is the we have seen the magnetic, that is the direction of the charge, force on the charge using right hand rule. Now key properties we shall see. Work done, the magnetic force is always perpendicular to displacement, so work done is 0. Speed cannot change the speed. Who cannot change the speed? Magnetic force cannot change the speed, only it changes the direction of the motion of the charge. Right? The particle, the trajectory of the particle in the magnetic field is circular or helical. Circular means like this. When it is moving perpendicular, when the charge is moving perpendicular to the magnetic field, then you will get circle. When the charge is moving at an angle theta to the magnetic field, then it goes in a helical path. This is called helical path. Okay, like this. Next, the Lorentz force. What is the Lorentz force? We have calculated Lorentz force, that is a sum of electric force and magnetic force. This is called as Lorentz force. Right. Now we talk about motion in a uniform magnetic field. What is the motion in uniform magnetic field? Just now we said If the charge is moving at an angle to the magnetic field, it will take the helical path. The charged particle trajectory is circular when it is perpendicular to the magnetic field. If it is at an angle to the magnetic field, it is helical. If it is parallel to the magnetic field, goes in a straight line. That means theta is equal to 0. This is circular when theta is equal to 90 degrees. This is theta other than 0 and 90 degrees. That means it lies between excluding 90 and not equal to 0 degree, not equal to 90 degrees. Not equal. Remaining angles, when we are throwing a charge other than these two angles, it will take a helical path. If it is 0 degrees, it will take a straight line motion. So magnetic force in this case does not act. When velocity is parallel to magnetic field, we call it as theta is equal to 0 degrees. Circular motion. When velocity is perpendicular to B, it moves in a circle. The charge will move in a circle. When the radius, then we can say if it is moving in a circle, we can come to one conclusion. What is that? Centripetal force, which is written as mv square by r, is equal to the magnetic force QVB. Here 1v and v get cancelled. So remaining what we can write here, I want the r value, that is equal to mv by qb. Right. Okay. So like this we got here. Similarly, we can find the time period also, because we know that to find the time period, we can find, first of all, V we will find. If you do V square by R, then you will get omega value. Omega is equal to 2 pi by T. From this we can find out the time period. Okay. So from that we will get here, instead of V square you write only V by R. V is equal to R omega. Right. So V already we get from this. V is equal to, what you will get? V by R, no? So you write R by V. You bring this V to this side. R by V is equal to M by QB. But I want V by R. V by R is equal to QB by M. Right? V by R is nothing but omega. So 2 pi by T. 2 pi by T is equal to QB by M. Now cross multiplication. We get T is equal to QB 2 pi M by QB. 2 pi M goes up, QB come down, T goes up. So T is equal to 2 pi M by QB. This is nothing but, from this we understand that time period is independent of velocity. In this formula V is not there, so it is independent of velocity. Right? In this context we can say one thing. If I throw two charges, one is at lesser velocity, another one is at greater velocity, then both will take the same time to reach this point again. But one will move with the lesser radius, the other one will move with the greater radius, and both will reach into the same point because the velocities are only different here. Time period is independent of velocity. Even though V2 is greater than V1, R is greater than R. For this both cases, T is constant. This is the beauty of time period independent of velocity. Next, here formula R is equal to mv by qb, omega is equal to qb by m, that is v by r. Then cross multiply, you will get this. Next, time period is equal to 2 pi m by qb. This is cyclotron frequency, angular frequency omega is equal to qb by m, that is 2 pi f. Omega is equal to 2 pi f or 2 pi by t. So it is independent of v and r. Angular frequency is not depending on the velocity of the charge and the radius of rotation of the charge. Right hand rule, thumb rule will applicable here. Speed remains constant here. Only the direction of the charge will be changing. Because of that only it is moving in the circular path. It is moving in circular path because of this reason. Only the direction of the V is changing, but the magnitude of V remains constant. The direction also changing because of the magnetic force acting on the charge. What is Biot-Savart law? Magnetic equivalent of Coulomb's law. Okay, this is called magnetic equivalent of Coulomb's law. Coulomb's law means, according to Coulomb's law, F is equal to Q1 Q2 K into Q1 Q2 by R square. Right? There we talk about charges. Here in Biot-Savart law we are talking about the magnetic field at a point P due to current element. So here current, we are getting the relationship between current and magnetic field. Okay, equivalency, we are getting magnetic equivalency of Coulomb's law. We are calculating the magnetic field from current element. This is Biot-Savart law. Magnetic field is directly proportional to current I, inversely proportional to square of the distance between them. It is inversely proportional to square of the distance. So B is proportional to I, B is inversely proportional to R square. Combining both, we got mu naught IDL by R square, 4 pi R square, mu naught IDL 4 pi R square. It is also using right hand thumb rule, field direction we can find out. Mu naught value is equal to 4 pi into 10 to the power of minus 7 Tesla meter per ampere. DL is a current element, I is a current. For a straight wire, we are doing application of the Biot-Savart law. For straight line, straight wire, B is equal to mu naught I by 2 pi R at a distance R from the wire. The magnetic field forms concentric circuits around the wire, the radius R. Biot-Savart law is the magnetic equivalent of Coulomb's law. Biot-Savart law is the magnetic equivalent of Coulomb's law for electric fields. Magnetic field of a circular loop. This is a circular loop. Circular current carrying loop. So current is moving in the clockwise direction and field is along the x-axis. Current I here, field B in this direction. B is maximum at the center of the loop. Decreases along x-axis as the distance from the center increases. Dipole behavior at large distances from loop. Dipole, north-south, couple, two poles. Axial point, that is mu naught IR square by 2 of square root over x square plus y square whole cube. This is field at a distance x from the center. X is equal to 0, then B is equal to mu naught I by 2r at the center. Maximum field at the center. Magnetic moment is equal to IA, M is equal to IA. Ampere circuitry law. Magnetic analog of Gauss law. Right. It's a fundamental, that is integral B dot dl is equal to mu naught I enclosed. So here it is a closed line integral in Ampere's law, and in Gauss law it is a closed surface integral. Gauss law is a scalar quantity, Ampere law is a vector quantity. It relates to E to the charge, it relates to B to the current. So it is a surface closed surface integral. E dot dI is equal to Q by epsilon naught. This is line integral. B dot dl is equal to mu naught I. That is the difference between Gauss law and Ampere's law. B field depends only on enclosed current. Symmetry simplifies calculation. Valid for steady current only. Applications. For straight wire, it is mu naught I by 2 pi r. Resistance R from the wire. Its solenoid is mu naught Ni inside. Outside it is 0, nearly equal to 0. And for toroid, it is mu naught Ni by 2 pi r inside only. The line integral of B around any closed loop equals mu naught times current enclosed. This is a solenoid. So uniform magnetic field. Inside the solenoid, uniform magnetic field is maintained. Outside, it is nearly equal to 0. Solenoid means naturally like this. Power magnet field only will be there. Inside it will be south to north. Outside it will move from north to south. Okay. South. Uniform magnetic field, nearly constant magnetic field inside the solenoid, mu naught Ni. Field outside, magnetic field is nearly 0 outside the solenoid. Current required, field proportional to current through the coil. Proportional to current, field, magnetic field proportional to current. Uniform magnetic field, that is equal to mu naught Ni, where N is the number of turns per unit length. Field inside nearly uniform and strong. Field outside very weak, nearly 0. Similar to ball magnet field pattern. For solenoid, the magnetic field is mu naught Ni. N is the number of turns per unit length. Electromagnets, inductors, relays. We use this. Force between two parallel currents. Okay. See here, these are two parallel, but here the current direction are opposite. No? When they are opposite, they will repel each other. When the currents are opposite to each other, they will repel each other. When they are parallel, that means they are in same direction, attract each other. How can you say this one means? Using right hand thumb rule. With the help of right hand thumb rule we can say very easily. Okay. So here see, this is the current direction. Current direction. Now it is here out of the paper. Here this side is into for this current, I1 current. For I2 current, what I will do? Again it is showing here out of the paper, and it is showing here into the paper. So here, unlike poles together, they attract each other. They attract each other. Okay. One is going into, one is going out of that. So they are generated here for both the wires. So that's why definitely they will So here, once again, here out of the paper, according to thumb rule, current flowing. Current is flowing in this direction, I1. Here also the current, suppose I2 also flowing in the same direction, parallel condition I am talking about. So here out of the paper, and after that the fingers are showing into the paper this side. For this wire, it will show out of the paper this side, same like this wire, into the paper in other side. So into the paper, out of the paper, they attract. Unlike poles, they attract. Next, key points. Force is proportional to product of the currents. F proportional to I1, I2. Force decreases with distance. Direction depends on current direction. Used to define SI unit of electric current. Here we defined electric current 1 ampere, that is. Actually 1 ampere means Q by T we defined. 1 ampere, 1 coulomb per 1 second, that is another definition we have done, right? So here one more definition we got from the formula also. This is the formula, right? F is equal to mu naught I1 I2 by 2 pi d. So based on this formula also we can define 1 ampere. That is 1 ampere is defined as a current which when flowing through two parallel wires 1 meter apart in vacuum produces force of 2 into 10 to the power of minus 7 Newton per meter between them. Two wires are there, they are separated by 1 meter distance, and the force between these two wires is 2 into 10 to the power of minus 7 Newton per meter. This much force is acting, that may be the attraction or repulsion. Then only we can say 1 ampere flow of current will be there through these wires. Okay, like this we can define. Thank you.